All right, let's jump right into this explainer. Today we're looking at an absolute stunner in the night sky, the Caldwell 20 complex. You probably know its main pieces, the North American Nebula NGC 7000 and the Pelican Nebula IC 5070, sitting about 2,590 light-years away from us in the Cygnus constellation. This isn't just another pretty astrophotography target, we're actually going to unravel a century-old astronomical cold case. To really wrap your head around the sheer scale of Caldwell 20, you've got to take a wide field view. Why? Because this complex covers an area of the sky literally 10 times the size of a full moon. It's massive. If you zoom in with a high-powered telescope, you'll just drill right through it and totally miss the bigger picture, this sprawling, magnificent expanse of glowing hydrogen gas that William Herschel first logged all those years ago. But, being that massive presents a rather massive problem. And this is the core mystery we're solving today. What exactly is the engine here? Figuring out what hidden power source could possibly be strong enough to ionize and light up this gigantic expanse of gas, well, that took astronomers decades. It really is the ultimate cosmic detective story.
Section 1. The Cosmic Continent. Let's map out the geography of this glowing structure first, just so we know exactly what we're dealing with. Just look at how clearly you can see those distant shapes in visible light. Over on the left, we've got the North American Nebula, NGC 7000. And separated off to the right is the Pelican Nebula, or IC 5070. It's pretty obvious how it got its name, right? That glowing boundary on the left looks exactly like the silhouette of the North American continent.
And because the resemblance is just so uncanny, astronomers actually leaned into the joke and named the subregions after Earth's geography. So you've got the Gulf of Mexico scooped out at the bottom, the Atlantic tracing the eastern coast, that super distinct Pelican's Neck over on the other side, and the incredible dense Cygnus Wall acting as Central America and Mexico. Those glowing borders, that's exactly where dense material is just being violently blasted by radiation. Moving on to Section 2, the Dark Divide. And here is where things get really interesting, because those familiar shapes, the continent, the pelican, they're actually part of a massive optical illusion.
This comparison brilliantly shows what's really going on. On the left, in visible light, we see what looks like two totally separate nebulae, divided by a dark, empty void. But when you check out the two mass survey data in near-infrared light, that's on the right, that dark void just completely vanishes. It turns out the North America and Pelican nebulae aren't two separate objects at all. They're actually one continuous giant molecular cloud.
So what's pulling off this trick? That apparent gap is caused by L935. This is a dense, completely opaque absorption nebula. Basically, it's a giant, dark dust lane parked right in the foreground, right between us and that glowing hydrogen. It acts exactly like a giant cosmic stencil. It casts a shadow that carves out the shape of the Atlantic and the Gulf of Mexico, completely blocking our view of the glowing gas and stars sitting right behind it. Which brings us to Section 3, star nurseries. Because you see, this complex isn't just some static backdrop. Those regions bordering the dark L935 dust lane, they are highly active stellar nurseries. When we peer deep into the dust using millimeter wavelength observations, we see a picture of total chaos. This data maps out dense molecular cores and powerful outflows. In fact, it shows that the Gulf of Mexico, that really opaque southern part of the dark cloud, is actually plunging inwards toward the main region, fueling an insanely high density of newly forming stars. Just look at the clues hidden away in these regions. The Gulf of Mexico alone is packing over 300 young stellar objects, baby stars, along with a massive 1.6 parsec long outflow. Then over in the Pelican Nebula, there's this dense clump hiding a suspected binary system that's firing off a quadrupolar jet. That means it's blasting out material in multiple directions with differing symmetry. Even the Atlantic region is hiding active infrared nebulae that are completely invisible to regular optical telescopes. It all points to the immense, violent energy locked up inside this dust. All right, Section 4, the hidden power source. With all of this glowing hydrogen, these massive sweeping structures, and active star formation, astronomers literally spent decades trying to answer one question. What single star is powerful enough to ionize this whole system? This kicked off a literal 100-year manhunt. Back in 1922, even the great Edwin Hubble got this one wrong. He thought the extremely bright nearby star Deneb was the engine. But later on, spectral analysis proved Deneb was totally the wrong type of star for the job. Fast forward to 1952, Sharpless and Osterbrook pointed at another bright star, HD 199579. Again, the ionization structure just didn't line up. Eventually, astronomers realized the true culprit had to be hiding directly behind the thickest part of the L935 dust cloud, and it wasn't until 2005, using infrared data from the two-mass survey, that they could finally pierce that veil. Armed with that infrared data, researchers drew a half-degree search circle right over the geometric center of the complex, smack dab in the middle of the L95 dark cloud. By analyzing specific infrared color signatures, they were able to filter out thousands of foreground and background stars. That narrowed the whole field down to just 19 highly likely candidates. They did follow-up spectroscopy on those 19. Most of them turned out to be cool, evolved red giants or carbon stars. But right near the center, perfectly matching the geometry of the sharp rims we see in radio continuum maps, they found candidate number 4. Now, in visible light, there is almost nothing there. It's buried under nearly 10 magnitudes of visual dust extinction. Basically, the dust is so thick it completely snuffs out almost 100% of the star's visible light. But the radio data strips that gas away, pointing like a giant neon sign directly to this hidden star.
And there it is, the Bajamar star. Catalog name J2055-51.3 plus 435225. And it's not even just one star. It's a massive binary system featuring an incredibly hot O3.5 type star, which is one of the absolute most massive and luminous classes of stars in the universe, paired up with an O8 companion. This absolute monster of a system has just been sitting there all along, secretly churning out the massive amounts of ultraviolet radiation needed to light up this entire cosmic continent.
To cap off this awesome detective story, our hidden giant finally got its due. The name Bajamar star was officially approved by the International Astronomical Union on April 18, 2006. After a full century of scratching our heads, the Caldwell 20 cold case was officially closed. But man, it really makes you wonder, right? If a star system this insanely massive, one that powers an area of the sky 10 times larger than our moon, could stay completely hidden from us for 100 years at just 2,590 light-years away, what other massive engines are out there? What else is secretly driving the gorgeous structures we see in the night sky, just waiting for us to finally peer through the dust?